Okay, chapter 9 is about transformations. And basically, we're going to look at three types of transformations. Let me just give you a brief overview of what that's going to look like. Um, cool. Have my pen going. One type of transformation we're going to look at is when you take like a triangle and move it. And we might move it horizontally like this way. When we move things like by sliding them along, kind of like a car goes down a road, it's called a translation. And that's the first type of transformation we're going to study in chapter 9. But another thing we can do is actually we could take the object and rotate it around some sort of fixed point, kind of like a clock does, like when the minute hand rotates around a certain fixed point. In this case, I'm rotating this triangle counterclockwise. So that's another type of transformation we're going to study, is a rotation. And another thing we might try to do is to flip things, like we might have a line like this, and we might flip this object across it, kind of like when you take a pancake and you flip it in the air. Well, this pancake would flip across this line here. And in this case, we have a triangle. So we'll also do what's called reflections. They're called reflections. And so those are some of the transformations that we're going to deal with in this chapter. There's one last one we'll talk about, and it has to do with making things larger or smaller. Like, um, like if you take this triangle and make the same thing but just smaller. And it's kind of what happens when you put things in a copy machine. Sometimes you make things smaller, sometimes you enlarge them. That's called a dilation. So those, again, these are the transformations we're going to talk about in this chapter. And these ideas lay the foundation in Algebra 2, because we're going to be doing a lot of these things in Algebra 2 as well. So hopefully you'll see how they connect together. This is kind of a connection between geometry and Algebra 2 and Algebra 1 in some sense. So it's a very important idea that we cover here. So anyhow, let's begin. We'll start off by looking at translations, and that's what this lesson's about. And we're going to go ahead and do part 1 today. So let's take a look and figure out how to do this. Translate figures and use vectors. Okay, the vectors will come in part 2 of the lesson. So our essential question, students will be able to translate a geometric figure using a rule and explain the process to another. Okay, so you want to know it well enough so that you can explain it to another. And how do you translate horizontally or vertically using a rule? Well, those are some of the things we'll learn and practice in this lesson. So let's try and look at that. So before we get to that, we need to go over some certain terminology so that way we don't get confused. And so when we're talking about transformations, there will always be two objects involved. One of the objects is the one that you started with, and one of them is the new location. And so the one that we start with is called the pre-image, and the one that we end up with, the new image, or the new figure, will be what's called the image. And I've written this in red ink on purpose because our textbook uses red to denote the image, and it will use blue to denote the pre-image. So you can always tell which one's first, which one's last. Blue will be first, and then red. And so anyhow, that's a little notation we use in our book. So there you have it. Blue for the pre-image. Image comes second. And so this is second. And of course, the pre-image came before the image, so that's first. Okay, that being said, let's move on. There's another notation we use. Since the blue figure comes first, and we don't want to get confused between that one and the image, we use a different set of letters for it. For example, the blue image we would use like A, B, and C. The image that comes afterwards we'll use A prime, B prime, C prime. And if it turns out that there's an image after that, you know, like we do more than one change, like you change from this position to this position to this position, then we just continue to use this idea here where we just add these extra tick marks. And so like if we moved again, the next one would be A double prime, B double prime, and C double prime. And so we start off with a pre-image, we move to an image, and then that image may move to a new image after that even. So, and you know, if we did it again, we'd use 3 tick marks and so on and so forth. It's a pretty easy idea. So those are some of the things that we do in our textbook. We use the blue and red figures, and we use these tick marks. So again, we use capital letters for the pre-image, and we use capital letters with tick marks for the image. Okay, so this can be a little bit confusing at first, so we're going to practice a little bit. Here's an example here. Now, what we have here is what the rule is. And so this says you take your x's and you add 3 to them. And this says take your y and subtract 1. And what that has, the effect that that has is that it moves an object 3 units to the right and down 1. Now what we're going to do is we're going to do a little bit to make this easy for yourself. I always recommend doing 2 things. We start off with the original coordinates. Okay, these are the original coordinates of A, B, C, and D. And because I don't want you to get confused, I'll go ahead and plot these points in blue. Just real quick. So -1 up to would be, this is where A is. Okay. B is at -1, 5. Okay, so there's B. And C is at 4, 6. 4, 6 right here. C. And D is at 4, 2. 4, 2. So this is where D is. And of course we would just connect the dots. And there we have, it looks like a trapezoid. Okay. And so again we use blue because this is the pre-image. Okay, well our new points, I'm just going to go ahead and use red now, just so you can get used to it. We're going to call this A prime though. A prime, B prime, C prime, and D prime. That's what we call this little tick mark up here. We'll just call it prime. It's just a new word that we use. Anyhow, get used to it. So we're going to find all these new coordinates. Now, this is pretty easy to do if you're systematic about it. Okay. So let's take a look. According to our rule, it says to add 3 to all of your x coordinates. That's what this rule is describing right here. So if you add 3 to this, you got -1 plus 3. I mean, you can do this in your head, right? We get a +2. If you add 3 here, we get a +2. Add 3 here, we get 7. Add 3 here, we get 7. And that's all you do. So this is the new x coordinates. And now let's do the y coordinates. The y coordinates say to subtract 1. Okay, well 2 minus 1 is 1. 5 minus 1 is 4. 6 minus 1 is 5, of course, and 2 minus 1 is 1. Okay, so now what we do is we plot these new points on our graph, and we'll see what happened. Okay, so A prime is at 2, 1. 2, 1, right here. So notice what happens. We went over 3 and down 1. Over 3 and down 1. And so you can almost do this real easy. You go over 3, 1, 2, 3, and down 1. So of course this is the new location for B prime. And so this location here is A prime. This location here is B prime. See, if we go over 3 and down 1, it should be right here. So it is. It's 7, 5. So here's C prime. And then D prime. 1, 2, 3, and down 1. So there's our new object. It's right here. Alright. And so you can kind of see that this object, this whole object as a whole, it moved over 3 and then down 1. Over 3 and down 1. Fascinating stuff. And this is what happens in video games, actually. Your video game has to keep track of your position. So sometimes when you're walking, it has to keep track of your coordinates. And so in your video game, there's basically a great big map involved. And your computer, when it's doing these games and stuff, has to keep track of where you're at. Because then it has to send monsters towards your position and try to kill you, right? That's how video games work. Anyhow, this is tied to computer programming. It's also tied to global positioning systems, you know, GPS stuff. So very fascinating stuff we're learning today. Okay, let's continue. This is a chance for you to try it. And so, whoops, I'm not gonna, what I want you to do on this particular problem is make 2 sets of coordinates. Again, this time it looks like you have just a triangle. But you're going to start off with like R, S, and T. They have their coordinates already here. And we'll write them down real quick. This is 2, 2, and 5, 2, and then 3, 5. Now, I should have probably done this in blue. And then you got the transformation. By the way, we do this little symbol to indicate transformation. Okay, so there undergoes some sort of transformation. And so we have these new points, R prime. Okay, we have S prime. And then we have T prime. Okay, right here. And so once again, what you're going to do is plot both sets of coordinates for this triangle. And what I recommend, since you probably don't have blue and red pens, kind of like I do, what I recommend is using like for the pre-image, I'd recommend maybe using a dashed line like this when you draw the picture. And when you have the image, which is the second one, draw a solid line. So use this one for the pre-image, use this one for the image. And so that way you could keep track of which one's which. And I often like to do shading as well to help me figure out which one's which. So I will shade in like this object, whatever it is, I'll shade it in. And I'll leave the other one in its original position. I'll leave it dashed and leave it empty. Okay, so you can stop the video and do this task before we move on, because you need it on your study guide to get credit for it. Okay, I'm not going to do that. I'm going to move on to our new problem. And now we're going to try to work backwards. So, this is kind of interesting. Some people have trouble working backwards. Okay, so we have to take care here and pay attention to what we're doing. So, in this particular problem, I'm going to draw this in red because what we have is the image. And remember, the image comes second. Okay? The image comes second. And the way that we get the image is by using this rule right here. And so we have, and notice they use the tick marks here, they have a segment. This time, instead of having a triangle, instead of having a quadrilateral, it's just a simple segment. So where is P located at? P is located at -3, 4. Okay, so that puts P, puts P prime right here. And that means Q prime is at 2, 1. Well, 2, 1 looks like to me it's right here. Okay, so here's Q prime. The question is, now here's this segment that kind of goes, whoops. Ugh, that's awful. Anyhow, there's a segment. Imagine this is straight. On your paper, you can draw it nice and straight. Where was the original pre-image? Okay, so what we do is we work backwards. Now, here's the rule. Now, again, this time we have P prime. Oh, and I should be drawing this in red. All right, let me redo this. P prime is sitting right here at these coordinates, and we have the coordinates -3, 4. And Q prime is sitting at, I've got a feeling it's going to look hideous, but anyhow, it looks all right on my screen. This is sitting at 2, 1. And then we use some rule to get here. Like, remember, we do this step here, we do this, it's a transformation. So now what we want is the original pre-image. So where is P sitting at? Okay, and where's Q sitting back? And so in a way we're working backwards. That's what we're doing. Now remember, whatever coordinates I had here, I would have added 4 to get here. So to work backwards, you just subtract 4. And so if you have -3 and you subtract 4, that's going to put this at -7. And if you take this one and subtract 4, you're going to be at -2. Okay? And then this one that says, okay, to go from here to here, we subtracted 7. And that means to work backwards, you're going to add 7. So you basically just do the opposite of what you have here. And we've been doing that in algebra for years now, I hope. Anyhow, so if we add 7 to this one, that means we were originally at 11. And if we add 7 to this one, we were originally at 8. So it looks like the coordinates of our pre-image would have been at -7 and then up to 11. 11 would have been right about here. So P would have been here. And then -2, 8 would have been here. And so Q would have been right here. Oh, I did a better job drawing it this time. And notice what happens. We basically took this pre-image and moved it over 4 units. 1, 2, 3, 4. And then we moved it down 7 units. Down like that. So that's how this rule worked. We went over 4 and then down 7. That's kind of related to the idea of slope, right? Are you seeing the connection? Anyhow, that's working backwards, and you'll have some problems where you have to work backwards. And so I think I'll give you a new definition now. Isometry. Isometry is an idea that's used throughout the chapter, and it basically means the triangle hasn't changed size and shape. It preserves size and shape. Let's take a look at that. Preserves size and shape. And we say length and angle measure, but if the lengths are all the same, then it's the same size. And if the angles are all the same, it's the same shape. So an isometry preserves same size and shape. So you'll notice in all transformations, the isometry is preserved between the two. In other words, you don't have a new triangle. I'm going to just draw a quick picture of this. You start off maybe with a right triangle. That might be a 3, 4, 5 triangle. And after you're done with the transformation, wherever you move it, this way, that way, clear over to here, it's still a 3, 4, 5 triangle. Okay. It hasn't changed size and shape. Okay, so that's what it's meant. That's what's meant by an isometry. All right, so write a rule. Okay, well now we're doing a slightly different problem, and now you have to keep track of which one's which. And it says write the rule now. So basically what that means then is we need to come up with we start off with x, y, and we need to tell what to do with x and y. Okay? And so the x's are either adding or subtracting, and the y's are going to be either adding or subtracting. So you're going to have to do right something like x plus or minus some number, comma, y plus or minus some number here. And that's what we're going to try to come up with. Now the way you do this, or the easiest way I think to do it, is to take a corresponding pair of points. I mean, this point A corresponds to this point A prime, right? Now remember which one we start off with? We start off with the regular capital letters and we go to the prime ones. In other words, we start off with this blue pre-image and we go to the image. So how do we get there? We'll start off by going in the x direction. We go over this way. How far? Well, it looks like to me we go 1, 2, 3, 4. But we're going to the left. So I want to indicate that by writing x minus 4. And after I go left 4, I then go up 1. So I indicate that by saying y plus 1. And that's how we do it. It's that simple. So all you need to do is look at a couple points. A's work fine. You could have done the same thing with the B's as well. You could have gone B to B and C to C. And the reason why this works is because the transformation is an isometry. So everything's going to be in the same spot still. Same length, same angle measure, so things don't change. So let's look at C for example. Does it work? We'll go subtract 4. If we go subtract 4, it would be 1, 2, 3, 4. So we go to there. The y coordinate says to go up 1, and that takes us to C prime. You see? So that's how we do a rule. We write a rule. We're going to have to look at the image and the pre-image to figure that out. Now it's real easy to accidentally screw things up, and students make mistakes because they go from this point to this one, and of course that would be just the opposite of what we had there, and so they're going the wrong direction though. So don't do that. Okay. Here's an example where you can try this. Again, you just need to come up, you're trying to come up with x, y, and the rule you need to come up with is to figure out what happened. How do we describe the transformation? Or in this case, the translation. And then you could use any pair of points. You could use like E and E prime. You know, how does that work? I'll let you try that on your own. And so I'm going to move on. Now we get to our essential question. Find the new coordinates of the figure by changing the x and the y coordinates according to the rule. And there you have it. The end. We'll do part 2 tomorrow.